So SoC, system on chip. So what is going to be system on chip? Having the system on chip, nothing but hardware plus software plus integration. So system on chip. The chip having there is a system. That is a concept. A chip having there is a system. Nothing but system on chip. So here the SoC is not only a chip but more on systems. There is chip, not only chip. The condition is, see the condition, there is not only chip but more on system. Nothing but chip plus software plus integration. So there are three devices, chip plus software plus integration. The combined together we have to say SoC. So there is nothing but chip plus software plus integration. And this is the overview of this SoC. So here there is a amplifier, filter, customer logic, PGA, so ADC circuits and SRAM memory circuits, etc. So these all are combined together in a SoC. That is why we have to say it is a chip plus software plus integration. Chip means a hardware parts. This is nothing but a software parts, and integration means both you have to integrate, and you have to, if any problems or you have to communicate with the other devices, these are all embedded in this part. So this is the three parts, chip plus software plus integration. So next, here SOC chip block. So nothing but we have to see about the hardware parts. So here first one is the embedded processor. So embedded processor, what is that embedded processor? It is nothing but a simple microprocessor, and inbuilt in this SoC, it will operate simple mechanical as well as electrical function. Control simple as well as mechanical as well as electrical function. So control electrical as well as mechanical function by using this embedded processor. And second one is the ASIC logic and analog circuitry. So ASIC means application specific integrated circuits, logic and analog circuitry. So for example, it is mobile phone. So by using a mobile phone, we have a specific task. So that is example of the ASIC, application specific integrated circuit for designing a particular circuit. And analog circuit, for example, it is a PLL circuits or some analog circuits, for example, whatever maybe. So by some analog circuits, we have to design by using this analog circuits. And third one is the embedded memory. So it is nothing but a non-standalone memory. So it is inbuilt of that the bus width is wide bus width as well as the fast memory of this SoC chip blocks. So here I am showing here as the whole system as well as memory as well as the processor as well as the input of IO pads, input output pads. So these are the some soft cores as well as hard cores. Here nothing but the third party peripherals. We have to communicate with the manufacturer, etc. So these are all embedded in a single core. We have to say it is nothing but a SoC chip blocks. And SoC software. So SoC software, the first one is the OS, operating system, and second one is the compiler, and third one is the simulator, and the fourth one is the firmware, and fifth one is the driver, and the protocol, and stack integrated development environment, and application interface. So the OS is nothing but operating system, and is nothing but here it is the OS is nothing but the operating system, and the compiler is nothing but, so operating system is based on the OS. We have to install the software. Example, for mobile phone, we have to install the Android software. We have to load the by using the OS. Okay. And second one is the compiler. So compiler is nothing but compile the programs, high level and low level program languages. And simulator, so nothing but simulate. For example, if you want to design some circuit, you have to simulate that. So simulator will simulate the what happens function for particular circuits. So this is the concept of the simulator. Whether you are giving some designing some circuit, whether the circuit is functioning properly or not, by using a simulator, you have to simulate the circuit. And firmware, for example, it is a TV having some remote. So there is a communicating between the TV and the customer by using this firmware means some small device. That device will communicate the software by using that device to communicate the system to particular hardware. So that's the name of a firmware. And driver. Suppose if we want to install a software, we need some driver circuits. So the driver circuit will communicate between the driver, one driver as well driver system as well as the another device. So if we, that particular device will communicate what are things you have to do like that, you have to complete. So if we install the driver circuits properly in the particular system, it will communicate the one device to another device. Nothing but next one is the protocol. So we have some rules and regulations framed for assigning a task, installing softwares. By using a protocol, we have to use the particular device communication, etc. So that is nothing but a protocols. And stack integrated development environment. Suppose if you want some software installation, other OS, etc., by using the stacked development, so many devices, multiple software devices OS we have to install. By using a stacked development, you have to install it that. And application interfaces. So by using the application interface, we have to install so many OS, etc. So next, SOC integration. So here there are three things. One is the whole system solution, another one is manufacturer consultant, and third one is technical supporting. Whole system solution is nothing but you have to, for example, SOC, suppose anything happens or some errors occur in the particular device or circuits, by using a core system method analysis, we have to find out where it is happening, where some errors will be occurred. So we have to analyze the particular circuit and we have to find out the solution or get the remedy. So by using a core system method, solution method, we have to analyze. And manufacturer consultant. Suppose I want to install some OS or some driver circuits. So we have some information. So based on we have to so based on this we have to consider the particular manufacturer. We need some information. So by using the manufacturer consultant, you have to communicate with the particular device. And technical supporting. Suppose I want to install some circuits, we need some parameters. For example, memory capacity requirements as well as the whether it will support the OS, everything we need. So some technical supporting. Suppose if we want to install a software, what happens? It will be we need some technical supporting. So this system will accept these parameters or memory capacity will accept these parameters. So everything by using technical supporting, we have to get the information. So by using the SOC integrations, so three whole system solution and manufacturer consultant, technical supporting, we have to get from this. So next one is nothing but technical advances. So technical advances says that today's chip contain 100 million transistors. So nothing but 100 million transistors in a single chip. So the transistor gate lengths are in terms of nanometer. So the transistor gate length is very reduced. So what happened totally? The number of transistors will be increased in a particular chip. So this has happened because of every 18 months number of transistors will be doubles as per the Moore's law. So based on the Moore's law, we have to know that the number of transistors will be increased every 18 months. This is the graph showing the devices per chip, and here the years. So here it is nothing but SSI, small scale integration, and medium scale integration, large scale integration, and a very large scale integration, ultra large scale integration, giga scale integrations. So there is the x-axis, they are mentioned in the stages of integration. So small scale integration, medium scale integration, large scale integration, and very large scale integration, ultra large scale integration, and giga large scale integrations. So based on this integration level, we have to understand that the transistor, number of transistors occupied in the particular transistor will be increased. So the devices per chip. So this is the concept. So now up to 2010 it is showing that the loss is 50 nanometer, now very much reduced that. So what happens? So based on the Moore's law, so number of transistors will be doubled. So what happens? Definitely the sizes also reduces. So this is the concept behind the Moore's law. So this is the y-axis, it is devices per chip, and the x-axis the levels of years, and it will be split up into different levels. So the number of years increases, and means what happens, the levels of integration also changes proportionately, because what happens, definitely the transistors size will be reduced, number of transistors occupied in the particular SOC will be increases. What happens, definitely the level also increases. So system presently system on a chip, small scale integration, medium scale integration, large scale integration, very large scale integration, ultra large scale integration, and giga scale integration. So next, consequences. So previously what we did nothing but components connected in a printed circuit on a printed circuit board now can be integrated in a single chip. So the hence development of system on chip. So previously what happens, suppose if we want to design some circuits, immediately we are going for the designing by using a PCB circuits. So we need the PCB circuits. What happens? So lot of space and lot of connections will be complicated. What happens? Definitely the size of the particular circuit will be increases. We cannot mount in a particular locations. So this will be increases the space of the particular device, as well as the speed, errors also coming. So in case of a system on chip, this everything, suppose I want to design a particular circuit, what happen, a system on chip, there is a default circuit will be there, you have to take from that, and you have to communicate with that, and you have to get the output, and you have to apply the test input, and we have to finally we get the output. So this everything will be mounted on this and integrated, and you have to communicate with the OS. What happens is definitely you get the particular circuits and you have to work together. So PC is, so this is the consequence of PCB into this SOC. So printed olden days they are using the printed circuit board. Now they are using the system on chip, very fast, as well as complicated circuit also inbuilt of the SOC, and in this very small space, so many number of circuits will be inbuilt. So we have so many operations, as well as system is very fast, and nothing, no error is not coming. And the laying out of this particular circuit also smooth finish, etc. So what happens is the very nice finish. So what happens, the appearance also good. In case of PCB, appearance also not good. So many errors will be coming. So this is the consequences behind this. And next one is the offline flow of large scale integrations. In large scale integration, there is three major part. One is the system level design, and second one is the front end design, and third one is the back end design. So system level design is divided into two. One is the system specification design and system level design. And front end design, you have to design a particular gate circuit. There is a resistor transfer level and verification, functional verification. After that, initial logic synthesis, initial floor planning, and the equivalence timing constraints for verification and verification. And third one is the backend design, design planning, layout placement, and routing. So here So specification, the first part is the specification. So how will you get the specification from the system level design? So we get the specification from the customer point of view. But from the customer point of view, get the specifications. From the customer point, we need some data. So they are requiring some data. So that based on that requirement data, we have to specification design and system level design. Next level is, so after getting the system level design, we have to levels. So these are the first level, these are the second level, these are third level. We have to segregate that. So this is the first part of the design of system level design. So that's nothing but a specification. This specification we get it from the customer. And the second one is the front end design. The front end design nothing but a digital RTL design, high level synthesis. So you have to design a gate circuits. So what happens if you design a gate circuits, you have to how many inputs and how many outputs, and after that I will give the inputs whether it is functioning or not. What about the delay? Everything you have to analyze. That is why the functional verifications. Anything you have to reduce the gate number of gates, or anything you have to reduce the time durations, or input pulse, etc. So this is nothing but a front end design. So after that, you have to analyze the floor planning, initial floor planning, physical aware of the logistics, aware that, and where you have to plan the particular gates and all, and timing constraint. That is why suppose you are giving some input pulses, what happens? The if you delay, based on the delay, the output will be coming, as well as if you want to reduce number of gates, or you have to check the input, etc. So based on this, we have to design the front end design. So here everything you have to analyze, timing constraint, and as well as the initial floor planning and initial logical synthesis and functional verification, and first step to the but high level synthesis. So this is the second step of the outline flow of the large scale integration. And the third one is the back end designs. So here, so what we've done previously is nothing but first you get the data from the customer point, and second one, after collecting the data from the customer point, we have to work and we'll get the outputs whether the customer satisfy the particular points, etc. So by using the RTL circuits and verification and testing only, we have to understand that whether it is functioning or not, whether the customer will satisfy their requirements, etc. And back-end design, after analyzing analyzing these steps, we are going for a design planning where we have to fix a particular gate, and where we have to route, where we have to connect. So how many buses is coming, and whether it is applicable, and whether you have to reduce the bus width, or whether the placement of particular gate is sufficient, or we have to shift anywhere. So like that you have to analyze by using so many algorithms there. By using a backend algorithm, you have to analyze and will get the and optimize and get the idea. So after that, initially test circuits and design planning is a test circuit. After that, there is a test pattern generator. So once you design a circuits, and we have to backend design is over, you have to apply a test pattern generator. By using a test pattern circuits, what happens? So it will verify that whether it is all the gates inbuilt in the particular SOC is functioning or not, or is there any errors occurred in the particular topic. What about, is there any the route planning, the planning, placement and routing is anything you have to changes, etc. So is there any crosstalk noises is occurring, and so like that you have to analyze. So physical verification, litho verification, and crosstalk noise analysis, and power consumption analysis, and gate simulation. So by using a test pattern generator, so we have to gate simulation. So what happens with the sign off verification? After layout of placement routing, first you have to place physical verification whether we place the particular gates and etc. route everything is okay or not. Is there any cross noises occurring nearest to the bus? So everything you have to analyze. And power consumption analysis. So once you design a circuit and verified everything is okay and placed, so finally what about the power consumption? So we have some objective. So you have, as per the customer point of view, also they also mentioned that this much the power consumption will be coming like that. You have to analyze and you have to check whether the customer requirement is satisfied or not. Power consumption analysis okay or not. So like that, first one physical verification and cross noise and power consumption analysis. Finally, the gate simulation. So you have to simulate the all the gates and we will get the output. So these are the first case. We have the specification, and second one is the logical design, and third one is the logical synthesis and physical design. The specification we get from the customer point of view, and logical design, as a design engineer will design a particular gate, and after designing the gate, logical synthesis. So by using a logical synthesis, there may be a cadence tool or silence tool. We have to design particular tool using synthesis, and after that verify. So and we will get the output. So after that physical design. So by using so many algorithms, we will be whether the placement and routing is optimized or etc. By using the algorithm, analyze. After that, verify the power consumption analysis and cross or not everything you have to analyze, and finally we have to design the physical design of circuit. So this is about the outline of the flow of large scale integration design. So next, here I am showing the system on chip one model S3C6410. So first one is the 16/32 base RISC low power high performance microprocessor. Second, the application includes the first one is mobile phone, portable navigation and devices and other general applications. So this is nothing but a mobile phone. This application include the mobile phones, portable navigation devices, other general applications. And third point, they provided optimized hardware performance for a 2.5 GHz and 3G communication devices. And this includes many powerful hardware, accelerators for motion video processing and display control, scaling, etc. And the integrated multi-format code supports the encoding as well as the decoding. And fourth, final one is the many hardware peripherals such as camera, interface, and DFT 24-bit LCD controller and power management. So this is the system on chip model, taking this model. So this will be having some of the features is given. So this is so many features, the camera facilities as well as encoding options, and there is a multi-core format codec, and here it is a video processing, display control signals as well as the communication devices. Here it is the application of mobile phones and navigation devices, etc. So this is about the system on chip. So this is the diagram of this overview of this microprocessor. This is navigation system, iPhone based on this. So ARM 1176J is at SA36410. So this app installed in that, and proportionately this will be communicated showing in the diagram. So this is the concept of the mobile processor. And benefits. So here benefits is nothing but there is a two parameters, speed and power. So when you are designing a SoC, main objective is nothing but the system is very fast as well as the power consumption also low. So the speed main parameter nothing but speed and power. So the if you design a particular circuit, definitely the speed will be increases, and proportionately the power will be what happens reduces. So based on the parameter only, we have to analyze the or designing a circuit. This is the concept behind the benefits. So once you design a circuit, the main objective is the speed and parameters. So without speed and power, we cannot design, will not be useful. So that is why system on chip is nothing but a very fast as well as the power consumption also very less. So based on this parameter to this speed and power, definitely we have to achieve the particular devices. So that is why nowadays the SOC is the main part of the electronic devices, and you have to implement so many devices. So currently the 5G as well as, so these are all the based on the ASIC SOC system design. So what happens generally is nothing but a speed. That is what then only it is we have to make up this all the parameters. That is a concept. That is why these are the main benefits brings is significant. So these are the significant in terms of speed and power and drawbacks. So we are studied about the drawbacks, some of the drawbacks. So the extremely complex, requiring amount of verification. So already the first slide itself we know that 100 million transistors in a gate. 100 million transistors means what happened? Definitely there is so much of transistors will be in the particular chip. So we are giving, for example, if you want to verify, once we design a circuits and verify the input also, definitely verify, because lot of array of inputs we have to simultaneously apply. So simultaneously we are applying lot of array of inputs means what happens? Definitely what happens? The system will be complex. So it's extremely complex, requiring amount of verifications. So that is why the concept is given. Extremely complex means millions of transistors there. So millions of millions and millions of input will be simultaneously applying. Definitely what happens, there is a complex requiring amount of verifications. So you have to check whether it is properly done all the gates, whether inputs are okay, everything you have to check. Solution is to design and verify the reusable inputs. So solution is to design and verify reusable. Some of the inputs you have to reusable, and based on the solution you have to design. That is the concept behind this. And major applications. Here it is nothing but a major applications. So the internet is very demanding applications. That is why I have shown here it is internet and broadband switching and BC architecture, digital home environment. So internet, there is MP players and cellular phones, handheld intelligent applications and internet applications. So in broadband switching, there is a cable DSL, and in BC architecture, these are the things. What happened in bad? There is easy graphics and chipsets, embedded memory. And in case of digital home environment, we have a digital camera and set-top box, a GPX, and high definition TVs, home networks, and digitally enabled homes. And so this is the concept of the internet age, a very demanding application. That is why I showed here the Mesoji plays a major role in case of the internet age. So this is the internet age, the handheld intelligent applications. So internet, based on the internet, these are the MP3 players, internet applications, handheld intelligent applications, and cellular phones. So based on this internet application, we have covered major parts. Okay. Next, speech signal processing. So speech signal processing, nothing but what happens. So suppose there is a signals. We have speech. We have some speech signals. If you want to amplify the signals, we have to convert the speech signal to some other parameters. So by using the SOC, we have to convert everything. And this is the concept of speech signal processing. We have to processing this speech signal into any other form of signals. By using this SOC, you have to convert this. And second one is image video signal processing. There is a image as well as video signal processing. Suppose if you want to convert some other form of signals from the inputs from the image as well as video signal input, from that we have to convert into some other form. So there is some other signals. So by using SOC, we have to process that. And information technology. Under this, there is a PC interface, communication, computer peripherals, and monitor controls, DVD controller. So information technology. Under this information technologies, nothing but PC interfaces, AC, USB, PCI, and ID slots, computer peripherals. So here under computer peripherals, there is a printer control, an LCD, there is a monitor control, and DVD control. So these are all under the control of the computer peripherals. So by using this SOC, you have to control all computer peripherals through SOC. Okay. So next, data communication. So this is the major part in the nowadays. There is data communication. There is a wireline as well as wireless communication. In wireless communication, there is 10 bar, 100 base, transmission DSL, gigabit Ethernet. So these are the fast connections nowadays. Through this, we have to communicate the information. So why it is happening? By using SOC, system is very fast. When you are communicating with this data communication, the system is very fast, and we have to transfer so many number of bits simultaneously. What happens? System is very fast. The receiver side also get the information very fast and without error. That is the concept of the wireless communication. So wireless communication, there is nothing but Bluetooth, wireless LAN, 2G application, 3G application, 4G, and 5G, 5 max. So nowadays it is going on 5G. So based on the SOC, system is very fast compared to the previous system. So what happens? But that is why the Bluetooth, VLAN, that is wireless LAN applications, and 2G, 3G, 4G, and 5G, we have to transfer the data from one device to another device without any input medium, so without any wires. So by what happens, definitely the very fast through this the SOC system design. That is the concept. So that is why system is so the concept behind main concept nothing but the SOC nothing but a very fast simultaneously processing data and store the input memory as well as the process the data also very fast. That is a main role played in the wireless communication. So that is about this. Thank you.